again, Graham and the rest of the West Midlands Strut, I think this is a great first for us to try doing this and opening it up to everybody. Seeing a lot of faces from around the country as well, which is good to see.
Yes, it is. So it's 7:30 now. Hopefully you can all hear me. I'd just like to say good evening. My name's Graham Wiley from the West Midlands Strut. Welcome to our first Zoom meeting. Tonight we've got Keith Vinning OBE to talk about PilotAware and electronic conspicuity. As it's our first meeting on Zoom, we might have a few tech issues, so bear with us if we do. Looks like it's working okay at the moment. But to stop any background noise interfering with the presentation, could you all make sure you're on mute? And then we'll have some time for Q&A at the end. I think that's all I need to say. So I'd like to hand it over to Keith now and start the presentation.
Right, thank you very much, Graham. Am I sharing my desktop? Can you see that?
I can see you.
So it should say situational awareness and electronic conspicuity. Is that right?
Yeah, everyone else is on mute, so they won't be able to say anything.
Right, well, thank you very much. And great to be with you all. I've got the presentation for around about 35, 40 minutes, and that'll leave time for questions at the end. And, you know, I'll take any questions, harder the better, and look forward to being able to answer them. So basically, what I'm going to do today is to just give a quick recap of PilotAware. When Graham asked me to do this, it was basically tell us what the new stuff is going to be about. So I wanted to actually look at, but now we've expanded it, it's going to be a recap of PilotAware, what it does, and then I'm going to look at other stuff. It's not all going to be about PilotAware. I'm going to look at strategic versus tactical situational awareness. I'm going to do something on signal obscuration, which is something that we're very keen to discuss at PilotAware. And then finally, look at the new stuff that we're coming out with in the near future from PilotAware. So just to remind you, we started PilotAware in 2015, and basically it was to produce a bit of kit that was at the lowest possible cost, because electronic conspicuity in those days was expensive, and some of it still is. We wanted to make it so that it was available to everybody, and it was it actually saw more than anybody else. And our challenge was to actually see anybody who was transmitting anything on any frequency. And basically 4 years on, 5 years on, we've kind of done that, because we've got, we can now see PilotAware units, of course, FLARM, FANET Plus, Mode S, and Mode C as a bearingless target. We can see Mode S 3D, which is a kind of a world's first for PilotAware, whereby we can actually show Mode S on a screen in flight. And you can see there, that's what it looks like. We'll perhaps discuss that later on. But we can now see all those 12,000 transponders that are out there that nobody could see before. They're there ready to be harvested, and we've harvested them with PilotAware Mode S 3D. You can also put it on your favourite flight bag. This one's Sky Demon, of course, excellent bit of kit. But it is also available on all the others, which is Runway HD, 4Flight, whatever flight bag, it usually goes on there. And in the latest bit of software, due to customer demand, we've now started to give everybody METARs. When you are in range of a ground station, you will get METARs on a screen like this for all METAR stations within 150 miles of the station from which you are picking them up. And they also go on to the PilotAware radar screen. So this chart here was produced in September 2019 and gives us the view of what that electronic conspicuity is like that we want to capture. And this is based on what we captured at the LAA rally and some work that we did with Airspace for All. And the numbers are rough, you know, roughly correct for 2019. Around about 19,500 or so aircraft in the UK register, excluding microlights, balloons, and sorry, not microlights, excluding hang gliders, balloons, and paragliders. And of these, about 58% have got Mode S. 16% have got PilotAware or FLARM, and that's 16% who've got PilotAware and 16% who've got FLARM. Mode C is a bit smaller. ADSB for GA was around about 5. And this was taken about from all of the aircraft that flew in to the LAA rally. So it was a pretty indicative view of what people have got in the way of electronic conspicuity. So PilotAware, we wanted to help everybody to see everybody who's transmitting. And also we have this desire that you take your baggage with you. So basically, if you've got an iPad, you might as well not have to buy another screen. If you've already got a transponder, then we can help you convert that to ADSB. If you've already got FLARM, we'll help you integrate that into PilotAware as well. So you don't have to go out and buy new products just because something else new comes along. So another tick there. So just to make it absolutely clear in your mind, if it's not already, what you will and will not see with PilotAware when you are in range of a base station or out of range of a base station. So this first slide here shows you if you're out of range of no base station at all, right? So you're on the Isles of Scilly. We haven't got one there, Mike. I'll let you get one. But we haven't got one on the Isles of Scilly. So if you've got your PilotAware on the Isles of Scilly, you will see anybody else who's got a PilotAware and they will see you. Just over 4,000 now have been sold. You will also see anybody who's got ADSB out. They will not see you. You will also see anybody who's got Mode C or Mode S, and this will be as a bearingless target if they're being interrogated from the LAA site down in the southwest. So if they're being interrogated, you will see them as a bearingless target, and you'll be shown on a screen they'll be shown as a height and a relative distance. Can't be absolute because of the fact that we don't exactly know the direction it's coming from. But we will tell you there's an aircraft getting closer and closer and closer, and it's 200 feet above or 300 feet below. Very much like the old zone system. So therefore, that's 60% of the aircraft you can see one way or another. But of course, that wasn't good enough for us, and it certainly wasn't good enough for the customers. They wanted to actually see other stuff. And with the aircraft that out of Leicester that flew into the glider, they were concerned that they wanted to see FLARM. So what we did next was to actually work with the Open Glider Network, who actually do detect FLARM through their stations. And I think they had about 120 when we first started. And they detect FLARM. So we spoke with them, and we spoke with Andreas Lackbach from FLARM. And FLARM don't mind them collecting that data because it's used for safety. And so what we do now is if you're in range of at least one PilotAware station, PilotAware Atom Grid station, you will be fed with PilotAware, with FLARM equipped data into your PilotAware. So now you will see FLARM equipped aircraft, whether they're gliders or whether they are GA. And those aircraft will so those gliders will be probably up to 60 kilometers away or even more. So they can be used very much for tactical, for strategic purposes. So now we saw gliders, and that takes us up to 70% of the aircraft that are transmitting. Then we thought what we wanted to do is to spend our limited resource on actually cracking that 58 to 60% of aircraft that are out there with a functioning Mode S transponder. Now, Mode S, as you remember, normally if you see it directly, you won't get a bearing. So we worked very hard. We tried to we went to NATS, but they wasn't interested. So we worked with a company called 360 Radar, who at the time had 900 stations throughout the country. And they're able to give us, by ICAO code, unique ICAO code from each aircraft, the latitude and longitude of that aircraft. We pick it up directly from our PilotAware here. We see the Mode S transponder, we look for its ICAO code, and then we look for a match by interrogating the ground station. And then when we've got that ICAO match, if we've got a match, we know where the latitude and longitude is, and we can then plot it on a screen. Once again, a world first when you're in range of an atom grid station. So what that did was to actually allow us to pick up the bulk of this aircraft here, and it really lit the skies up or lit the screens up when we introduced that last year. We've now got 200 stations in the UK. We've got about 30 in Europe, and they're going in quite well. Until recently, they've been going in at 3 a week. So we will have 300 by the end of 2021 to give us, really good coverage. And then I'm looking for 400 by the end of 2022. Now, these are done by the community. They're done by you. PilotAware will provide the electronics for free. We'll provide the antennas at cost. But it's great because it's the community that are doing all of this. And that's absolutely fantastic. So we all need a slap on the back for that. And of course, this year we introduced the METARs, and they come from the ground stations as well. So if you want to have the best of the best, and you've got a trig transponder, then you can just use the trig transponder. And if you buy a £25 cable from Farnell, you can connect it to your PilotAware, and it will give you the GPS to make your trig transponder ADS-B out. So you get the best of both worlds. You have to set that to be what they call a SIL level of 0, which means it's an unimproved GPS. But that, the tests have been done by Airspace for All, and it's as good as damn it as with a approved transponder, which would be a SIL equals 1 or a SIL equals 3. But for £25, you get ADS-B out, ADS-B in, PilotAware out, and then you get the others in. If you've got a FLARM, you can do exactly the same thing. Take a £25 cable and connect that to the FLARM, and then you'll get FLARM in, FLARM out, ADS-B in, ADS-B out, PilotAware out, and Mode S 3D in, and that is the best electronic conspicuity that you are going to get in the world, in my opinion. But you do need to be near to an atom grid station. And of course, you'll get Mode C as a bearingless target as well. So that is a little bit, there is our matrix that is our equivalent of the one that the CAA did, which had lots and lots of ADS-B everywhere, which made ADS-B look good. But basically, this is, if you read left to right, if you've got a PilotAware Rosetta, will you see a PilotAware Rosetta? Yes. You'll see a CAP 1391 device. Yes. You'll see FLARM and Power FLARM. Yes, if you're in range of at least one atom station. Mode C, you'll see yes, but it'll be bearingless. Mode S, you'll see yes, but it'll be bearingless. Unless you're in range of a ground station, and then it will be just like ADS-B, because you will be giving it its latitude and its longitude. You'll see ADS-B transponders with a SIL equals 1, and you'll see ADS-B transponders with SIL equals 0. So unlike other ADS-B receivers, we do not reject something just because it's got an unapproved GPS. And then you can see the other green bits for other people who have got products. And the main thing that we want to do is to actually get as much integration as we can. So I've put that screen up, but it shows that you need to be in range of a ground station. So let's just tell you or remind you, if you already know about the ground stations. We have 200 ground stations out there, and the ground station itself is called an atom. I can't remember what the acronym is, but it's whatever. But it's an atom ground station. And then the grid is the secure network that actually links it all together. We've done a huge amount of work over the last year. This is now totally encrypted. You can't get into it. It uses the same encryption as banks. and so it is phenomenally secure. That part of the network will not be spoofed by anybody. So on a receiving station, you will have 3 antennas. The one antenna will receive anybody who's transmitting on 868. That's all the FLARM stuff. So we pull in all of that data, and that will probably go 100 to 120 kilometers to receive. It's a really high gain antenna, and it will receive all that FLARM information. In the middle, we have another antenna, and that receives anything to do with 1090. So that'll be all the mode C, all the mode S, and all the ADS-B stuff. And we pull that in, and then we go with that data. We'll pass that data back to 360 radar to contribute to those stations that Phil has got at 360 radar. And we've now got 1,300 in total throughout the country. So we have a fantastic MLAT capability within the UK. The information is also passed to the Open Glider network and used for MLAT with 360. And then finally, we have this third antenna on 869.5, which is on the industrial, scientific and medical frequency, 869.5 megahertz. And that rebroadcasts to anybody with PilotAware. So PilotAware, if you don't know, it's a little small single board computer. It's a computer in the sky. It's not just an electronic conspicuity device. So we can use that to do some very, very exciting things, as we will show you in a moment. But PilotAware will be fed with information about all planes that it doesn't see directly, as I showed you before. And then all of that goes back to our servers, and that can be used for lots of exciting things. That is a concatenated picture of the reach that we've got. I think it was in October. And you can see that this bit here, guys, as we'll all know, actually it's that bit there. That is the most busy airspace on any day of any week of the year. That is the biggest airspace, busiest airspace as far as GA is concerned in the UK. You get other corridors that are busy, but that's the busiest bit. And you can see the concentration of stations that we've got. And then you can also see that there are areas where, Mike Mould, this one's at you. We need something going on down in the southwest. Wales is we've got some more stations going in Wales. The northwest is getting good, and then these spaces here are airfield, Stansted. Obviously Heathrow and Gatwick, Birmingham, blah blah blah. This area here, which is where the Flyer magazine decided to do their trial, there's no antennas down there because that's Salisbury Plain. And we need some antennas there, and then the Solent area, we need some antennas down there because you've got Bournemouth and Solent radar. But Kent is growing strong, and for the majority of places where people fly, it's getting quite good. But we certainly need more. And by the time the next flying season comes, we want to be able to fly Peter Robinson all the way down to Edinburgh, all the way down to the Isle of Wight, and not miss a gap. So it's looking quite good. We're also putting them in mainland Europe, but more coverage, as I said, is required in Wiltshire, the southwest, Hampshire, and we're still working extremely hard with everybody to improve. Oh, by the way, if you do want to install a ground station at your site, just let us know through ogn@pilotaware.com or keith.vinning@pilotaware.com, and we'll send you the free stuff. And of course, what you get out of it is that you get more protection around you, and you also get a virtual radar server. And as one man said to us, that's a better radar coverage than some of the RAF have got. And I've been talking today to RAF Leeming about putting one in there. So that's enough about PilotAware for the moment. I just want to go to the second bit now, which is all about the different types of electronic conspicuity, or the styles of electronic conspicuity. So you might have read this recently. one of the biggest safety enhancers in flying, blah, blah, blah. You can read that. And if it is at the front of your mind, that is because it was written by Steve, and it was at the back of the last back of the last LAA magazine. And, you know, as usual, Steve is a good strategic thinker. And he's saying to us, you know, what you've got to do is think about where you're going, think about what you're doing, think about even checklists, because if things go pear-shaped, you're a lot better equipped if you have prepared. And I think we would all agree with that. And today I've been speaking to EASA, as I have over the last few weeks on a couple of projects. And they have this view of situational awareness as being strategic and tactical. And there is a big difference between the two. So here's a few guys that are at a competition in Slovenia. And they are, I mean, count them, there's 100 or so more there. And they are flying tactically, totally and utterly tactically. They have the rules of the air, they're all going around the same way. So they have some things going in their way, in their favor, but they have to think tactically. And tactical situational awareness really can also be called collision avoidance. Yeah. And the Mark 1 eyeball is always the final stimulus for action. We were talking recently about the Airbus A321 that nearly hit a glider as it was going into Frankfurt. And it doesn't matter what they had, they didn't see the glider till the very last minute, could do nothing about it. The glider didn't see them, or the glider did see them at the very last minute. It was 50 meters, 50 meters. And so in that situation, it doesn't matter what electronic conspicuity you've got, it is always the final stimulation for action is the optic nerve going to your brain and getting you to do something. FLARM is great. You know, we love FLARM. FLARM provides help for the tactical collision avoidance. It's really, really good for gliders who are close in thermals, and it tells them which is the nearest glider, and it uses that through cooperative measures. So FLARM is very, very good for that. But guys, GA flying is not a video game. It's not a video game. If you want to go and do that, just get yourself Star Wars, this is the Battle of Endor or something like that. If you want to do that, do it there. Don't do it in the air. Don't think that any situational awareness or collision avoidance stuff is going to help you out. Because if you're going to fly your PA-28 through that lot, mate, you know, please, let's hope you got a lot of luck with you, because it was really drive you crazy trying to fly through that lot there. So that's tactical. What is strategic situational awareness? So I think, as Steve said, like if you've got this fantastic weather map, yeah, and we hope to be able to do that with PilotAware soon. If you've got that on your screen, you're not going to get your plane and just keep flying until the last minute and go, whoops, I'll turn around now. And exactly the same way, if you're flying to Farnham or you're Farnborough or you're flying Elstree, that is the most busiest bit around here. You're not going to fly down there and just wait until Sky Demon says, beep, 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 beep. It's not going to happen, guys. When you fly down there, you'll use all those words that are in the CAA Skyway code, and you'll all fly at different heights. You won't use, you know, natural turn points. You'll fly very, very defensively, as Steve tells us to do, to think strategically, to fly defensively. This is PilotAware on your tablet. This is the screen we give you. It'll be on an app soon as well. But here is a flight that I did 2.5 years ago when I flew from Bidford to Enston to drop off an antenna. And as I was flying, I got a load of voice alerts telling me, number one, that there was an OGN in range. And then multiple gliders. It was going alert, 10 o'clock, alert, 10 o'clock, alert, 10 o'clock, alert, 10 o'clock. And there were multiple gliders thermaling or landing. Now, I'd looked at my NOTAMs before, of course, and I knew that this was a glider competition at Shennington. And all of these were the gliders returning from the competition. So here they all are, and glider pilots, can't blame them, but they don't turn the FLARM off when they get on the ground. So this was all the people on the ground or just above the ground or landing. And these were the people returning, coming back in from the glider competition. Okay. So when you see that, basically you don't go over there and say, well, let's go and have a look what's going on over there. You keep away. You keep away. This is basically saying, look, let's pretend there's a danger zone over there and let's just keep away. And this is strategic situational awareness, not just knowing when a glider is going to hit you or when a plane is only 2 kilometers away, but where is the action happening so you can keep away. And at the same time, keep that Mark 1 eyeball open for the glider that might be coming over here whose flarm isn't working or they haven't got a flarm. So this is very, very important. In the same way, this is the kind of all of the aircraft you'll now see with PilotAware. We see so much aircraft that, you know, the screen can get kind of cluttered. I've left this one open so you can see all the different types. But first of all, here's all the ADS-B. This is 24,500 feet, so it's 24500, 36900. So all of this stuff here, yeah, it's all ADS-B. I know it's ADS-B because these are all jets. You can see the vectors, they're all going fast. So let's close down the filters and get rid of those. We don't want to see anything above plus or minus 5,000, 2,000. So we get rid of those. The other ones have got lower lubber lines or lower vectors, so they're flying much slowly. So let's assume that these are gliders again, all very slow flying stuff. And look, this one's turning in a tight tunnel, so you can see that's probably a glider, probably down at Bicester or something like that. Then what you get then is this one I do know is a PilotAware. Once again, it's flying slow. I think it was a Ninja. And we were doing some tests when we were developing Mode S 3D. And then these are the Mode S 3D targets. This is how we present them onto our PilotAware radar screen. And it's the same way as it's presented on EasyVFR. So these little rings here, these are circles of ambiguity. And basically these grow as the data ages. So there's two things you can look at here. One is the lubber line, and that's a long one. That's going fast. It's at 18,600 feet. Forget it. It wouldn't be there if you got your filters closed, but that's a jet. And it's going down. It's a Mode S, not ADS-B. It's a Mode S, and it's somewhere within that circle, probably at this end of the circle because jets don't turn around quickly. This one here is also a jet. It's going fast, but not so fast as that one, because it's 3,800 feet, probably going into a circle into Birmingham. And this one here is probably 5, 6, 7 seconds old. And it's here somewhere in that circle, probably at this end. So keep your eyes open for it. You won't see anything beyond 4 kilometers, but you're at least tactically aware that it's there. And then these two here, lower lubber lines. This one I would guess is something out of Oxford. It's probably a Diamond. And this one here is probably flying about 110 knots at 2,900 feet. But these are Mode S. And the thing is that these you would not see with any other electronic conspicuity in the world. And don't forget your Mark 1 eyeball. Okay, so that's the difference between tactical and strategic electronic conspicuity. Second thing that's important is the obscuration. So we was talking with Airspace for All about obscuration and about the Barton trials, and they were seeing a lot of obscuration. And one of the good things about our network now is when you're flying somewhere like the Midlands or you're flying in that area where around Elstree, you're going to be being picked up by about 5, 6 stations. And we can tell by testing what we see from one station to what we see from 2, 3, 4 or 5, what obscuration you're getting from your plane, whether you're being seen in all directions or just one direction or whatever. When you're being picked up by 8 stations in different directions, you're being picked up all the time from the ground, but of course not air to air. So what is this obscuration? So there you've been reading that. It's a noun, it's something getting in the way. Now, all electronic conspicuity, whether it's FLARM, PilotAware, ADSB, works at a high frequency from 869 to 1090 megahertz. Now, this is line of sight stuff, okay? Doesn't go through brick walls, doesn't go through engines. It gets bent by metal in the aeroplane, and it gets attenuated or reduced when it goes through your body. So basically, those, you have to make sure that if you've got this thing on the top of somewhere high, like the control tower at Western, it will go for 100 kilometers. PilotAware will go for 100 kilometers, no doubt at all. And FLARM will, because it will actually go and it'll be totally unobscured. It's exactly the same for the GPS signals, which are a little bit of higher frequency. They're at 1575 megahertz, but they still will get affected in the same way. So let's just have a little example of how that's done. If you've got carry-on equipment, it will be affected adversely by the effects of obscuration. Not might be, it will. Okay. And if you don't understand what this is, you will not be getting the most out of your carry-on equipment. So here's your physics lesson, and hopefully it's not too bad. So like all good mathematical models, let's assume a carry-on A-speed conspicuity device, such as PilotAware or CAP 1391 device or FLARM, and they transmit what we call isotropically, and they transmit in all directions at the same time, like the ripples going around in a pond, but not quite like that. But for this model, it'll be okay. Radiates in all directions. So now let's wrap that in a plane. You'll recognise that as a VANS. You put it in a plane, and let's assume somebody has said, "Oh, I've bought my device. I'm now totally protected. I'll throw it on the, or not, I'll drop it gently on the parcel shelf behind, and everything will be all right, won't it?" Well, no, because what happens is those signals will be severely blocked by the metal of the airframe. It's a VANS. It will be blocked by the body of the passengers going forward, because they are basically 75% water, and radio waves don't like going through water. That's why we have to have sonar. And it'll also be blocked by the big lump in the front. So the best thing to do there is to move it. And if you move it to the top of the dashboard, then of course it's got a much better chance of getting out, and being seen in the most, being seen in the most effective area where you're going to get crashes, which is going to be here, here. And so if you put it here, that will be much better. But metal, carbon, liquids will cause obscuration and attenuation. All right. So it's much better if you can put those antennas outside. All right. So there we go. That's probably the best place on a VANS. The best place would be actually at the top of the tail, but that can only be done when you are building it from scratch. So if you are doing it afterwards, the best place is going to be under here. But when you do that, you must make sure that your antenna is vertical. Now, it doesn't matter whether it's vertical up or down, it's still vertical, but it mustn't be lying down like this. We see a lot of people who put their antennas up here and they lie them down like this thinking they'll work. They won't. It's like Polaroid glasses. Turn them sideways, they don't work. So your antennas must be vertical and be better to put them outside. Now, the BMAA and the LAA, both for the past 2 years, have allowed you to drill holes into your aeroplane to put these in, with no special requirements other than to let your inspector know, and to not drill, obviously, through areas that are important. But the flat areas on the bottom of the sports cruiser or VANS are fine. Our friends at EASA are at this moment, or have been over the last 6 months, making changes to CS-STAN, so that EASA planes from next year will also be able to do this, to put these in. They are making a distinction between non-approved electronic conspicuity, that is FLARM, PilotAware, and anything else that comes along. And it's going to be a light touch for those. If you've got an approved bit of kit again, then the regulations are already there. But if you have an EASA plane and you want to put antennas on here, you will be able to on a light touch with the new CS stand that's coming out. Same goes for the antenna, the GPS. GPS on the back here is not going to be any good at all because the GPS signals are coming from the satellites. So that also should be on the dashboard or somewhere where it's got a clear view. So here's the obscuration takeaway advice. Make sure your radio has got a clear line of sight, whether it doesn't matter which one it is, PilotAware, Cap 1390, whatever, or FLARM. Make sure it's got radio line of sight, otherwise you'll get obscuration. You must use, if possible, use internal or external antennas. If you've got a PA28 and you don't want to drill holes in at the moment, you can use internal antennas and put them to the left and the right of your cockpit, and also on the windscreen, and also put the GPS on the dashboard. That's fine, so long as you're able to put external antennas on. And by external, I mean external to the device. And make sure your antennas are vertically polarized, and know the limits of your chosen system. If you can't put external antennas on, know that and make sure you get a clear radio of sight, because that's the only thing you can do. And we sell kits for PilotAware to be able to do that. Right, on the final hurdle, the last stuff to take us to our 40 minutes. Now talking about PilotAware new stuff. We're going to talk about new stuff in the cockpit, new stuff on the ground, new software, new features, and further integration. So PilotAware innovation is driven by the fact that, number one, we use this 869.5 megahertz ISM frequency. So what's special about that? Well, the special thing is it's regulated. We can't do what we want to. We have to meet regulations, which we've done, but it's unlicensed. And that means that we don't have to tell anybody if we stay within the rules. You don't have to tell everybody when we put an antenna up, which you do have to do if you're on the 1090 or 978 megahertz frequency. So we can go and make statements like, I'm going to go from 200 to 300 antennas in a year, because that's just down to us, because we're staying within the rules. More importantly, it's the blue sky thinking about solutions and the art of the possible. Now, this is where the clever guys, not me, the clever guys in PilotAware like Lee Moore, Chris, and so they actually really do think about the art of the possible, like we did with Mode S3D. We couldn't see Mode S transponders. So we thought, what do we need to do to see them? And that's when we thought of using MLAT and made it work. And the combination of the ground infrastructure and the airborne computer that is Rosetta. We've got two great things on our side. Number one, we've got a computer up there. That's the single board computer we used. That's hugely powerful. It's more powerful probably than the computer I'm giving you this on now, because it's about 5 years old. And that can actually really process data very, very quickly. Also, this 869 megahertz frequency that we're using gives us what we call 10% duty cycle. That means for 10% of the time, that ground station can actually be putting up data and it's still legal. At the moment, we're using about 1.5%, even when we're putting up METARs. We've still got a lot more to go. So the combination of the ground infrastructure and that computer that's Rosetta gives us lots and lots and lots of possibilities. And thirdly, that's that integrating your existing stuff wherever possible. Okay, you might have to think about what you have to do, but you don't have to go to an engineer to do this. You can integrate it with your AV map. You can interface it with your Garmin, not Garmin, you can interface it with your Trig or other things. Garmin's a bit more difficult because they don't like other people integrating with stuff. But if you buy Canardia or other equipment like that, whereby they will allow integration, you can bring all these things together very inexpensively. Then you get the community involvement. The community involvement, like, you know, the Southwest Strut, like the guys at Western Zoyland, like the guys, you know, at Halfpenny Green and Wellesbourne, who have actually got together and for a couple of £100 have put a ground station in and allow all of this stuff to happen. You know, whereas in the United States they do it, but it cost them millions, billions. But the community getting behind this has really made it happen. And finally, customer demand. You know, we don't always do what the customer asks, but what we do is we find out what the customer really wants, and then we'll say, yeah, we'll put that into the stack, and we'll do that, like we did with Flam, like we did with Metars. So what have we got? Number one, Rosetta will remain the mainstay of PilotAware. I'm not telling you don't buy anything because something else is better is coming along. Rosetta will always remain the mainstay of PilotAware because it's low cost, high functionality equipment for all. Okay. And whatever we do and whatever we have done will always be what we call backwards compatible. That means if you've got a Rosetta now, if we bring something else out, don't worry, we'll make sure as much of it is backward compatible as possible, and it'll be inexpensive. But we need to use more of the stuff that you already have. And so I'd like to just introduce you to a new product that's coming out probably the first part of next year, depending on testing and other stuff. This is called Rosetta FX. So what Rosetta FX does, it's a product that goes in line with anybody who's got existing Flam equipment. So that's quite a lot of gliders in the UK, probably 1,800, and a lot more in Europe. And as you've seen, the gliding community, they tend to use their electronic conspicuity very, very much as a tactical. And it's very good because they'll get a beep, 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 beep. That's the closest glider. But the challenge that we had a couple of years ago was that's all very good, but how do you tell them about the PA-28 that is going to fly through them like I showed you earlier on? How do we tell them about that? Because the PA-28 won't have Flam. But we have to tell them, hey, you know, strategically there's somebody coming along, or a paraglider who can't do anything about it other than big ears and do very, very tight turns to make himself visible. How do we tell them that something is coming along? Well, Rosetta FX hopefully is designed to do that. And the way it works is, here's the Rosetta FX, and it fits in between, in this lead here, which goes between the existing Flam unit and the Flam display. And it basically fits in there and harvests and injects data. So it doesn't do anything to this at all. This still works as it's always done, using predictive algorithms, and works fine. But the Rosetta FX will inject everything else. And that means that with this product, you will get, in a glider, you will then have obviously tactical Flam in and out, but you'll also get PilotAware in and out and all that contains. You'll get strategic Flam in, so they'll be able to see gliders 60 kilometers away or whatever. You'll get ADS-B in, direct from the Rosetta FX, because we're going to put an ADS-B chip in it. That's an ADS-B in chip. And we are also will inject Mode S3D when in range of the base stations. And they'll get Metars. So now basically this is taking integration another step. We've looked at the way Flam works. We're not actually changing the way Flam works, but we're injecting all the other stuff so that now the gliders can actually, if they use an electronic flight bag, can see the planes plotted on here strategically. They'll get voice alerts. And if they've got a glass cockpit, which they do, which is generally usually an UDI or a Kinardi or whatever, they will get the Flam and the PA-28 coming through on the glass cockpit. So this is what PilotAware is doing for greater integration in Flam. It's a move away from the way we do things at the moment. It's small. It's only 10 centimeters or 4 inches in old money, 2 inches wide and about 1 inch high. It's light, very light, and it's low powered. And so that's what glider pilots tell us they want. They haven't got any power. And so it's very lightweight. We have got a 12 volt in case they can't get enough power from the FLARM. But that then has one antenna that will connect to the grid, and it will also connect directly to pick up 1090 for the ADSB, and it'll pick up the Mode S from the grid. So that's what we're doing. And so these guys here will be flying around tactically like they were before, but if the PA28 comes through, they'll see it. Secondly, we've got Rosetta DX. So Rosetta DX is for drones. This is being used in 2 or 3 places where we're doing it at the moment. It's not on general sale, but it is being used professionally. It's really mainly for the professional drones, and it's being used for experimentation. It's being used to actually give greater conspicuity to the drones. And hopefully it will help the beyond visual line of sight business cases. And basically what this does, again, you can see how small it is. It weighs 32 grams. It's got PilotAware in, PilotAware out, strategic FLARM in, ADSB in, Mode S 3D in, and also any data that we want to put up from the ground stations that might be useful for drones. We can't say what that is at the moment, but it does mean that when drones are being used, and we're not talking about hobby drones here, we're talking about, professional drones, and when they're in range of ground stations, this is actually giving them all of the other data about all of the other GA that's around, and so that's pretty good. You'll notice we brought out a PilotAware app recently so that you could update your software very, very easily, very quickly. That's been very, very well received. So we're spending a lot more time now with a couple of our supporters to actually bring out a new app. And the app will actually not only do software upgrade, but license upgrade, diagnostics, easy configuration, able, make it easy for people who are hiring planes to move from one to the other. And also has things like an effectivity polar diagram. It will show you whether you got obscuration. It'll tell you what you're seeing in every direction. And we'll have a radar screen, we'll put METARs in and flight analysis, and then what have you at the end. So we're working on the app to make it look a lot better than it is at the moment. And then there's PilotAware AirGrid. So PilotAware AirGrid is something we're doing with a very large company in the UK. And we've been doing this now for kind of like 6 months. And we're building on the success of the Atom Grid. And we're using that power of the PilotAware P3i, the computer in the sky and the good data that we can put up. And we're going to be doing an airborne detection and rebroadcast. Okay. So think of that as like a plane in the sky, an Atom Grid station in the sky. So we thought that the satellites would be a great way to see drones when they're very low down, because as you look down from the satellite up here and you look down, you can see the drone. Look from over here, you can't see it because the church and the factory's in the way. But if you look up here from the satellite, you'll probably see it electrically. But we can't afford satellites, but we do have planes in the sky. And at 4,000 feet, you can see a huge way. If you've got no obscuration, we've been doing some tests at Bath, and at Bath, you can see the coast and it's everywhere. So this plane here acts as a Atom Grid station in the sky. And so therefore you reduce airframe obscuration. You can see stuff at low altitude. Nobody is going to be seeing this drone here from these ground stations, right? But he will. And when he sees it, he'll be able to tell everybody else it's there. And not only that, this drone will say to him, because it'll have PilotAware on it, PilotAware DX, and it'll say, I'm down here, I can't see a ground station. And this one here says, I can, this is what you can see. So, that shouldn't have happened. So this is another slide, which you can look at if you watch the video. This is air grid. Once again, the same kind of thing. And it's actually it's showing the art of the possible. It's showing how, with multiple stations and multiple aircraft and drones, you can actually show the drones where the aeroplanes are and show the aeroplanes where the drones are when it can't be done because of obscuration with other things. So basically, PilotAware air grid, it's an atom ground station in the sky. That's pretty exciting. That is really captivating some important people. So finally, just as we're coming up to time, the Atom Grid stations now is getting seriously integrated and comprehensive. This is what the stations look like in October. So you can see, as we said before, lots and lots of stations going in. Thanks to Peter Greenrod, we've had quite a few going up in North Wales. This one here is at RAF Valley. We're talking to Leeming today. We've got one just gone in at High Airfield north of Bryce, Little Rissington. One is going in there, and so we're getting quite healthy. Whoops, we're getting quite a healthy implementation, and you can see right the way down to ground level. Look, this is an aeroplane. This is actually Denham. So here's an aeroplane, look, doing circuits and bumps, boom, 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 boom. You can see him right the way down to the ground. And not only can he see him right the way down to the ground, but anybody else with a ground station around here will see him as well, because we'll be telling them about him. So strategically, if you're flying along and you see that, you know which runway they're on and that kind of stuff. So we're getting really good. And the stations, we can detect all electronic conspicuity. So we can detect ADS-B from transponders with an approved GPS. This is called DF17. We can do ADS-B with an unapproved GPS. We can tell which is a CAP 1391 transmitter because they're DF18. We can tell PilotAware, we can see FLAM, we can see Mode S, we can see Mode C. And with that, and that national database, and this is the kind of stations that will detect you over Banbury. Okay, you'll be picked up by 1, 2, 3, 4, 5, 6, 7, 8. Right, and the obscuration from this one here at Bicester, so which has dropped out, but these still see it. So you're seeing about 8 or 9 stations, and this is typical when you're over in that area of the state. But with this national data, we will be able to let you individually know by your ICAO code the fidelity, i.e. the truth of your individual electronic conspicuity. Is it good? Is it bad? Is it being picked up? Has it got obscuration? We can compare one with another. We can compare GPS types. Is a GPS that's unapproved any worse than a GPS that's approved? We can determine the flight obscuration by aircraft by EC type. How good is my aircraft? Is it? I think it's good. What is it? We can determine the SIL and other transmitting parameters which are required now by the LAA and the BMAA to approve your EC. And we'll be able to provide polar diagrams for electronic conspicuity transmission, and we can update data. We'll be able to update data to you and then anything else possibly that you want. Okay, so that's all, folks, and thanks for your patience. Don't forget to keep your most important things safe and well, because this is your Mark 1 or both of your Mark 1 eyeballs. Because those are, without a doubt, the most important bits of electronic conspicuity that you have and will be. The takeaway is, flying is not a video game. So assume that everybody's out to crash into you, stay safe, and fly safe. And thanks very much for listening.
Thank you, Keith. That's a really excellent presentation and some superb stuff coming along in the pipeline. I'd like to open it up to Q&A. First of all, I don't know whether you've spoken to anybody at Shawbury. I don't know whether there's any pilots on. I know there's some said they might be able to join us today, but I believe that their helicopters are equipped with FLAM, and they actually switch their ADS-B off. I guess it's because it's, I'm not sure of the reason. But FX might be really interesting to them because they're flying around at low level. And if they can put that into their FLARM, then they're going to be able to detect everything else, like GA flying around Shawbury.
Yeah, that was the reason for doing it. We do. I don't know whether Peter Greenrod's on, but we do actually pick them up a lot at Welshpool. There's 3 stations: Welshpool, Druids, and the Mind. And now there's one at Lambeda. And so in Wales, they tend to go from Shawbury and go out over the Wrekin and then into Wales. And we pick them up a lot. And so we can.
I pick them up. I'm just thinking if they can see us, it's even better.
Well, that's right. Now, what I was saying was we pick them up because they fly down the valleys. And if you've got the site at Welshpool, they will be able to see in the valley that goes up to Dolgethley. Yeah. But they will be obscured from perhaps the Mind. But what's happening is the information from Druids is being passed to the Mind. It's being passed to Warden. It's being passed to Sleep. And so, therefore, they can see around the mountains, as it were.
Yeah. And
so, if the helicopter takes off from not Sleep but from Shawbury, he will be able to, if he's got FX in it, he will be able to see his mate flying or even landed at Welshpool Airport. Not because he's seen it directly, but because it's been relayed to Sleep and it's back to him.
I think at the moment that they've just got TCAS 2 on the helicopters, but also the grobs, the tutors that they use for the UBAS, they've got FLARM as well. So it could well be interesting to them.
Yeah, it's fantastic. You know, I mean, we're actually, you know, we're not in the game of trying to kill every other electronic conspicuity going. What we're doing is saying, you've chosen that for a reason, but now let's add something else.
Yeah. Okay. So if anyone else has got a question,
there's a load of questions in the chat. I don't know.
Do you want to address those first then?
Well, I can read them down. Quick question before I start. I'm based at Welshpool. Is West Midlands my home strut, or is there another one in the area? I think it'd be West Midlands, wouldn't it?
Yeah, you're quite welcome to join us. As soon as we've got out of this COVID business, you can come along. We have our meetings at Halfpenny Green, but this seems to be a successful form, so we might continue with these as well.
And then he said there's another strut at Shobden.
Yeah.
Yeah.
I'm not sure quite which is the quickest.
Yeah. And then this is great. Thanks, Graham. Graham Park. Atom is air traffic overview management. I should know that, but so that's good. Steve Slater says you must get a more recent pick, Keith. Okay, Steve. Sorry about that, mate. Question for later. In view of obscuration, why does Keith think that the Sky Echo does not have a connection for an antenna, either internal or external to the aeroplane? Why does Keith think? I don't think it has.
I'm sure it hasn't.
I'm sure it hasn't. Graham Park to everyone. Question for later. In view of obscuration, why does Keith think that Sky Echo 2 does not have a connection for an antenna? I don't think it has. And I haven't seen one.
It's internal.
I know it hasn't. I was asking why you think, because it would seem sensible to have one.
Oh, sorry. Sorry, it's a rhetorical question.
Yes.
Oh, why? Well, I think I'm not going to talk about other competitors' products, really. But I think what they've done is the Sky Echo is a really nice little, looks really nice, and it's, it's dinky and that, but they've used technology from iPhones and things like that. Looks really, really good, but they don't. And I don't know why they've done that. I think they've just tried to make it look nice and neat. I don't know. But it doesn't have any, I mean, if there's anybody on there here from Sky Echo that can answer that, it's not for me to answer, but they don't have one. Okay, so from Peter G, is the PilotAware app iPad, iPhone only? No, it's not. It's Android. So lots and lots of people use Androids. The thing with Androids is that, it's dependent on what other apps are working at the time as to how efficient they are. If you are going to use an Android, we always recommend that you turn off the power saving facility, because that does not do good things to the Wi-Fi. But no, a lot of people use use Androids. So it's not iPad and iPhone only. What does SIL 1 achieve over SIL 0? Okay, so SIL 1 just means that the GPS that you've attached to your Mode S transponder with extended squitter, it means that that has got a approved GPS. So to my mind, that's good in a way, apart from if you have an approved GPS, if that GPS starts missing a few packets, it'll stop working. And then your ADS-B will stop working. With SIL = 0, it doesn't have that integration, and so therefore it won't. It'll still keep working. The work that a guy called Steve Hutt, as a lot of people you know, did along with Abe Price from NATS, I think about 3 or 4 years ago, said there's not much difference between SIL 1 and SIL 0 because the chips in the GPS are virtually the same anyway, because they're GNSS chips. So the thing about this is that people get hung up that if you have got a TCAS device, I don't know how many people here have got TCAS devices. I couldn't even afford one. I couldn't afford one. But if you've got a TCAS, it will ignore a SIL = 0 ADS-B. So, let's say Graham's flying along in his Foxbat and he's got his PilotAware connected up to ADS-B. He's putting out ADS-B and an executive jet flies over Rotherton. It will ignore you if he's got TCAS because it's saying, I can't accept his GPS because it's saying I'm unapproved. Now that does seem a bit silly to me. So if that answers your question, the difference is that TCAS will ignore it. And I assume, although I'm not an expert in this at all, if and when NATs do start to monitor ADS-B, which they're not doing on a regular basis, I think they also will ignore anybody who's got a SIL = 0, which is also very, very inappropriate as far as I'm concerned. Does that answer the question? Okay, I'll assume it. Let's have a look. When do you expect the app to be available on Android? It'll come out on iPads first, because iPads are, in our opinion, they're certainly much more stable. Because the thing about an iPad is Apple write the software, they also produce the hardware, so it always integrates. But with an Android, you'll have Sony, or you'll have Samsung doing the hardware, and then the software comes from somebody else. So it certainly will come after it's on the iPad. I presume Peter G has said, is PAW app iPhone only? It is at the moment, but it will be Android when we can get somebody to port it over to Android. I don't know when that's going to be. Does Rosetta do anything that the Classic can't? Short answer, no, it doesn't. We bought out the Rosetta because people wanted it in a single case. That meant that we had to just slightly change the PCB so it would fit. Didn't change anything in there. I still use a Classic in my sports cruiser. The Rosetta is better in the fact that it has got a better Wi-Fi. It's got an integrated Wi-Fi. It's also got Bluetooth, so the Classic doesn't do Bluetooth. And you end up getting more ports so that you can actually connect to other bits of equipment. But basically, the Classic can do the majority of what Rosetta does, apart from Bluetooth audio. However, that's not the important thing. The important thing is keep your software up to date, because all of the software is backwards compatible. The software will work with Classics, and it will work with Rosettas. Does my PilotAware Classic do everything the Rosetta does? Yes, same question. I can't find an Android app for PilotAware. No, there isn't one. If you're an Android expert, then speak to me. I get that PilotAware users can see many other types of EC. What does it send out so others can see a PilotAware equipped aircraft? ADSB question mark? No, it doesn't send out ADSB. And we have no plans for it to send out ADSB for reasons that I have said many, many times, is that we do not believe that ADSB is the future. Might sound as if that's going against what the CAA say, but it's not just me saying it. It is ICAO. So ICAO announced fairly recently, and it's in the latest CAP 722 document, that ICAO have prohibited the use of ADSB below 400 feet. The FAA in the States last year also prohibited the use of ADSB on drones because of spectrum congestion. So what does it send out so the others can see a PilotAware equipped aircraft? It doesn't. But if you've got ADSB in your plane, you're going to have an ADSB receiver. PilotAware is as good an ADSB receiver as anything else, and you get all the other stuff as well. So we're not, we don't do ADSB, we just do PilotAware. But as you've seen, hopefully we are doing everything we can to get as much integration with other things. What increase in PilotAware and other devices are you expecting as a result of the CAA 50% off offer? What increase in PilotAware? That's a good question. There was a big demand, huge demand in the first 2 or 3 weeks. It has dropped off slightly, I expect it to build up for Christmas, and then I expect to be a mad rush in February. So there will be an increase. I can't tell you what it is. It's going to be. Nobody can. But whatever you want to do, you choose what electronic conspicuity you want. If you fly gliders or you fly close to gliders and you want to buy FLAM. Yeah. If you want to get ADSB out, get an approved GPS for your Trig or your Funker or whatever, or your Garmin, because they'll all qualify for the 250 off, or get yourself a CAP 1391 device. Because whatever you do, it is going to increase that pool of electronic conspicuity that we can all see. So from Stuart, given that this technology is likely to be more and more relied on, particularly to allow safe drone operation, what safety integrity is there in the PAW product and system design? What safety integrity? I guess you mean by that, because you've used the word integrity, are we going to go for a SIL equals 1 GPS, for example? Not at the moment. If it becomes necessary, we will. It's early days for anything with drones. I've been looking at both the Future Flight and Cesar. They've been doing lots and lots of webinars. I talk regularly with Cesar, talk regularly with the ARSA, and it isn't anywhere near close now as to what they're going to be doing. It really, really isn't. What PilotAware will be doing is continuing with the art of the possible. We will be showing what can be done. If then, from that, there becomes a standard, then yes, we will start to spend money on integrity and other stuff, more integrity. And we'll put that into the system design. That will clearly put the price up. We'll keep it as low as possible, but that is going to start to put the price up. So I don't know if that answers your question. Kevin Stewart, Kevin, did that answer your question?
Hi there. Yes. I mean, my background is in safety electronics. That's what I do for a living. So I'm interested in obviously I'm aware it's based on a Raspberry Pi and you've got SDRs and so on. But I mean, it's great for what it is, and I understand the approach you've taken, and it's an eminently sensible way to go and to have got to the position you're in. But obviously, going forward, if people are starting to rely on it more and more, then you've got to have some integrity in the design and the system. I mean, obviously, the designers that are involved in this have an awareness of it, but it starts to get more formal, or it's required to be more formal as people are making more use of it in more serious situations.
Yeah,
and I was thinking really for the drone use eventually, that's what people are going to be particularly interested in, because there's no one overseeing what's going on.
You're absolutely right in that. And you know, within that as well is not only the integrity within the electronics, there is the integrity in the spoofing, there is the integrity in lots and lots of things. And a lot of the work, well, I say a lot of the work that's been done, a lot of the talk that's been talked is to have multiple technologies. So, you know, there's technologies using 5G, there's technologies using lasers, there's technology using satellites, there's technology using, you know, the standard ADS, well, not ADS-B so much in drones now, but there is the technologies that are being used to actually multiply all that together. And it's quite a long way off. And even in the drones, there is the drones that are flown beyond visual line of sight, and then there's the autonomy, there is the swarming, and there's all of that. And it's they're talking about talks at the moment, as far as I can see. I may be wrong, but that's what I'm seeing. What we're doing is getting on with it and then producing very, very exciting stuff like AirGrid. And, you know, will PilotAware ever become a standard? I don't know. Possibly not. Will 978 be the standard? Which is kind of what I suggested in a way to, well, not in a way, I suggested it to EASA 2 years ago. Because 978 is an aviation standard. It's not available in the UK at the moment. It is an aviation frequency, and it does use a modulation technique called FSK, which gives you lots and lots of bandwidth. But, you know, as soon as you start to get into a regulation and say, right, we're going to regulate this frequency, you then get really hamstrung with what you can do. So in the way in the States, they've got 1090 for the jets and everything above 18,000 feet. They've got this second frequency 978. It's still regulated. You don't have to use it unless you're going to go into controlled airspace. But it's nice to have a third frequency where you can actually do stuff that isn't mission critical, because PilotAware isn't mission critical. If you're going to buy PilotAware, don't buy it, because when you buy PilotAware, we tell you don't rely on this. It can go wrong at any time. Yeah, it's your Mark 1 eyeball. Even down with any of this stuff, it's your Mark 1 eyeball that is going to help you out. You only use this stuff as an aid, and we only sell it. Everybody who buys PilotAware or downloads the software signs up to say, you know, basically, this is to be used as a secondary surveillance aid only, not primary. I wouldn't use any electronic conspicuity as primary. You know, it's still up to you to actually do it. So if a drone's flying towards me, whoa, you know, you're quite right. That is a completely different ballgame.
Yeah, I must admit, I like your approach of see what's possible and have the ability to operate in an unregulated way to explore that and see the performance you get, because that's how you drive things forward. I mean, working in a highly regulated industry, you get nothing done. I mean, crumbs, we just want to change a single component. We're into tens of thousands of pounds and months of time and, you know, hundreds of documents. So I think you've taken exactly the right approach, and it's far more exciting and interesting to see what's possible.
Well, it is finding out the art of the possible, so that then when the regulators see what can be done, they then turn around and say, okay, let's see how we can now do this officially. Yeah. And a lot of the stuff we're doing now at absolutely no cost to the regulator, you know, and little cost to the general public. We're really sorting out the human factors and all that kind of stuff, which, you know, people are now starting to think about electronic conspicuity, and then thinking about electronic conspicuity, they then go back to thinking, yeah, but it is my eyes that are doing it. You know, I can't rely on this stuff. So it's an interesting time. It's an interesting time. Thanks, Stuart.
Definitely.
Final question. If you buy a Rosetta, you get a year subscription with it. Can you delay the activation until later in the year when there are more flying opportunities? It's £12 a year, threepence a day, right? Yes, you can. Yes, you can. I had a guy in Sweden yesterday, bought a PilotAware Classic second-hand, and he said it's never been used. And so I spent 10 minutes changing his email over to him, and then he said, oh, how do I get my license? So I spent another 15 minutes licensing it for him, and he ended up paying nothing because it never been licensed, right? Cost me half an hour, right? So he saved his £12, and it cost me half an hour to do that. So the answer to that one is, if you buy a Rosetta and get a year subscription, it isn't until you actually activate it that it starts. But it's £12 a year, and we need that for our beer and pizzas because we don't make money anywhere else.
I saw one other question, Keith. Somebody asked about how do you get the audio from PilotAware, and it just cost me £5 to put an audio cable from the tablet into my radio interface. And
yeah, so I don't think you see that, but that's actually the size of a Rosetta with the end cut off. But there is a little whoops, there's a little jack here. It's in the instructions, by the way. There's a little jack there, and that's a 3.5mm jack. You take that jack, but we don't sell cables because you can get them from Amazon Basics for about £4. And then you take that jack and you put it into your 833 radio, or you put it into your intercom, or you put it into your Bose headset or your Sennheiser headset or whatever. And then you will get your voice alerts from PilotAware. Alternatively, as Graham's done, take a jack from your iPad, which I presume is using Sky Demon. You take that from your iPad, the same cable, put it into your 833 radio or into your headsets or whatever, yeah, so long as they have got an 8-ohm input, and you'll get them that way.
The advantage of doing it from the tablet, getting the Sky Demon warnings as well, so you get the terrain.
Absolutely. No, I agree with you entirely. Yeah. I agree with you entirely.
And I would advise everybody to have the audio output, because you don't want to be staring at a screen while you're flying. You want to keep your Mark 1 eyeball out the cockpit. And then you get the audio warnings to maybe guide you to where you should be looking.
Audio warnings are imperative. You know, I fly all the time with audio warnings, because it's a bit like when we all used to go to the show where the Vulcan was, you know, where you go to an air show, or put it like this, you go flying and you might go flying and you don't see anything. But when you sit in the garden on a sunny day, you see loads of planes. You really do. But the reality is you don't. You hear loads of planes first and then you look for them. And it's the same in the sky. Your voice alert wakes you up, you know, traffic warning 300 feet above. That is telling you there's traffic close at 300 feet above. That then is a bearingless target. That which, by the way, Sky Demon won't give you. So there's an advantage of I use the PilotAware as well. So the advantage is that you then keep a lookout, and it does work. But you know, you keep also, don't fixate on any plane that you get a visual alert from. You know, if you get traffic 3 o'clock, 500 feet above, don't just keep looking over there and thinking, where is it? Because there might be something over here that isn't transmitting anything. It's all about, you know, I find that there was a big debate going on about this PilotAware stuff, or this FLAM stuff, or this whatever the stuff about 2 or 3 years ago, saying that it'll stop people looking out the cockpit. Graham, do you look out more or less?
I keep a better lookout, I think.
You do, don't you?
Like you say, it wakes you up. Sometimes you can get into a situation where you're perhaps just staring ahead and you've forgotten to do your scan, and then all of a sudden you'll get an audio warning. You think, well, I better look out to the left.
That's right.
Yeah.
And it's amazing the stuff you don't see.
Yes.
It really is.
It is. Yeah, it saved me a number of times, aircraft that I wouldn't have seen in less than ideal visibility. I know where they are, so I can take avoiding action and not get close to them.
Can you tell me, quick question, can you tell me, I've got the aircrew device for my display.
Oh, yeah.
How do I get FLARM onto that? Because there's no facility for paying the FLARM subscription, or can't I get FLARM onto it?
You can get the FLARM. Have you got PilotAware?
Not yet, no.
Okay, so the way you would get FLARM on it is to buy a PilotAware.
Yeah.
And then you will get FLARM and everything else.
Mm-hmm.
And then that will connect into the aircrew. What's your aircrew connected to now then?
Nothing at the moment. I've just got it.
Oh, right, sorry. So
I haven't got out to the aeroplane with it yet.
no, okay. So great. The aircrew is a great device. It's designed by Mr. Rose.
James Rose.
James Rose, yeah. And he's done that with our help, and he's doing some other exciting developments as well, which, you know, we help each other. You can take a cable from PilotAware, so everything that PilotAware sees will then be translated onto the aircrew.
But the FLARM subscription, you say,
No, you don't
need a FLARM subscription.
No, the FLARM subscription is only with the CAP 1391 device Sky Echo 2.
Right.
With ours, you don't need a subscription for FLARM. But you have to be in range of a ground station.
Right.
So where do you fly?
Halfpenny Green, based at Halfpenny Green.
Yeah, so Halfpenny Green's fine. Yeah, there's a new station going up at Rock, which is Stourbridge, and we're going to put one in at what's the place beginning with H by Clear Hills. One's going to go in there. So as we build more and more, you'll be okay.
I believe, Pete, that with Sky Echo, you've got to pay a £30 subscription, £30 a year to FLARM, and you pay that to Sky Demon.
Yeah, but if you haven't got Sky Demon, it's a bit of an issue, isn't it?
It is.
Yeah.
Yeah. If you haven't got Sky Demon, you can do the same deal with Easy VFR.
I don't have the reason is I don't have space in my cockpit for a tablet. So that's why I bought the aircrew device to sit on.
Okay, so you need.
So that's my issue. I don't have an electronic flight bag that I can.
So you need something to drive the aircrew.
Yeah.
Yeah, PilotAware. In fact, it's only PilotAware. I can't think of anything else that would drive it.
No. With FLARM. Yeah.
FLARM may do. Have a word with James. What you need to know is, you see, if you have a FLARM, have you got FLARM on your plane then?
No, I don't. No.
So you'd have to buy a FLARM at £1,500.
Yeah, I don't want a FLARM. No.
No. Okay.
I'm trying to find some way of getting the information into the aircrew device.
Yeah. So the answer is PilotAware. PilotAware is it.
Keith, is the PilotAware compatible with Runway HD?
Yes. Yes, it's incompatible with all of those major flight bags: Runway HD, Sky Demon, Easy VFR, 4Flight, AirMate. There was a South African one we did it to recently. Another one called Fly is Fun. Basically, there is a standard NMEA messages that would go in. Anything that will work with FLARM will work with PilotAware, because there's a FLARM message set, there's a GDL 90 message set. So any of those will work, Steve.
Okay.
The only difficulty we have tends to be Garmin, because Garmin is a pretty closed system. They don't like anybody going in.
Okay. Is there anybody else want to ask a question? Don't see any more.
If I may,
go on.
just briefly, going back to one of your earlier slides about positioning of antenna. If you have the antenna, which appears to be in an excellent place underneath, next to where most people have got their Mode S antennas down underneath, if anybody's flying above you, I tend to fly quite low, 2,000 feet, 1,500 feet or whatever. If anyone's flying above and you happen to have a metal aeroplane, you're in it, and an engine block, are they likely to see you?
Well, this is once again what I find. Yeah, I fly a sports cruiser. What kind do you fly? What kind of
sorry, I've got a Pioneer.
a Pioneer? Okay, so that's a wood aeroplane. Yeah.
It is.
So therefore, it'll go straight through the wood. Number one. Okay, but it won't go through the engine. It'll be deflected around the engine. But once again, it's kind of like, yes, you will be told about that stuff, but strategically. Yeah. So there will be some obscuration, but there won't be the obscuration because you'll be seeing them when they're 4 or 5 kilometers away. And that's when you have to look for them.
Right.
Yeah. So I find that is the best place to put it. If I'm going to build another airplane, I'll put it on the top of the tail.
What about a wingtip?
Wingtip will be fine. Yeah,
I can get in there because I built some ducting in to do that.
Wingtip will be fine. You need to have a ground plane there, of course, because external antennas are monopoles and they need a ground plane.
Yes.
Same as your radio does. But yeah, that's fine. That's fine.
Okay. Thank you.
Okay, if there's no more questions, then I'll bring the evening to a close. Thank you very much for attending. I think we've had about 30 people, which is rather good. What I plan to do
you've had 84 actually, Graham.
Wow.
84, yes.
That's fantastic. The plan is to record. Well, we have recorded this, so I'll post this up on various places. It will be on the West Midlands Facebook page as soon as I can get it there. So if you know anybody that would have liked to have attended and they couldn't, then you could point them in our direction so they can have a listen to this.
Alternatively, as I was saying to the guys earlier on, in non-COVID times, I usually do 2 talks a month, 2 struts for the BMAA, for the LAA and whatever. So if anybody wants me to do another one, it's ever so easy. I don't have to drive 250 miles to Linton on Ouse or, Sherborne in Elmet. It's ever so easy to do it from the office. So if anybody wants me to do it again, just ask me and we can set up another one.
Excellent. Thank you very much. Okay, then, if there's nothing else, I'll say good night and see you all again sometime. Let's hope we get flying soon.
Thanks very much, everybody.
Hello,
Thank you very much. That was a great evening. Thank you.
Thanks,
Thanks, Graham.
Bye.
Thank you.
Bye.
Thank you.
Thanks, Keith.
Mike.